So what we're doing today is, we'll see if it's going to take all day. We'll see if we get it finished or not today. Now, when we look at the first page asks us to determine whether the relationship is a function. The relation is a function. So we know it's a function if we have one x value going to a y value, yes? We cannot have two x's to one x to two y's. Because if we have one x value going to two y's, it is not a function. But can two x values go to one y value? Yeah. Because one x cannot go to two y values. Because the same x value cannot go to two y values. It's not a function. But it's okay for two different x values to go to the same y. That's fine. Because we could have the point 4, 6 and negative 4, 6. So let's look at this here. So 3 is going to 8. Negative 7, 14, negative 2, 8, 1, 14, 10, 8. So the x values are, well, I'm going to write them out here to the side because we had 3, negative 7, negative 2, 1, and 10. We had these 5 x values, yes? So 3 went to 8. Negative 7 went to 14. Negative 2 went to 8. 1 went to 14, and 10 went to 8. So is this a function? Yes, it's a function. Because even though we have more than one x value, or more than one x going to a y, it's fine. I just can't have one x value going to two different y values. We cannot have the x value repeated. The x value cannot repeat. So here I have 1, 3, 4, 5, 1. Well, wait a minute. Do I have an x value going to two different y values for this one here? Yeah, so is this a function? No. Anytime we have an x value going to two different y values, it is not a function. It does not work. Any questions on 1 and 2? How about 3 and 4? So looking at number 3, would this be a function? Do we have an x value going to two different y values? I only have one x value. I only have one line going from each of these x values, yes? So this, would it be a function? Yes, because each one of these x values has exactly one y value. If it has exactly one y value, it is a function. How about number 4? Does each x value have exactly one y value? Because 2 is going to, 3 is going to, 5 is going to. So this would be, is this if we had this here, then it wouldn't be, because 2 is going to two different values. Because as long as each input is going to an output, each input is going to one output, 1 to 1, it is a function. It is a function. So any questions on 1 through 4? 5 through 8, determine whether it is a function. So when we looked at a graph, we did what? The vertical line test. Can I draw a straight line up and down? And any of the points or the line only crosses once. So as I look at this here, okay, it only crosses once here. How about here? Once, 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 once. So is this a function? Yes. Okay, let's look at this one over here. Is there any point along this graph here where it crosses more than once? No. It looks like it could right here, yes? It looks like it could, but if we actually zoomed in on the graph, made it bigger, we would see that it's increasing. It's just small. It's just small. And it works all the way across. So this one here would be yes. Any questions on these two here? We like these two? Okay, let's look at these two here. Straight line. How many times did it cross here? Twice. Is this a function? No. As soon as we find that it fails the vertical line test even once, it only has to fail it once, it's not a function. So even if it worked for everything else, it would still not be a function, but it doesn't. It actually fails right there too. How about number 8? No. Because the vertical line crosses the graph twice. And the technical name for this would be a hyperbola. How do we feel about 1 through 8? You feel okay with this here? Taking good notes? So we good with 1 through 8. Okay, let's look at this one here. And again, you're going to get to use this on the test. So take good notes. So looking at this here, we want to find the domain in range, the x values and the y values. Now, when we look at these two here, we want to find the x values and the y values for this graph. Now, for number 8, since it's just a set of points, we're going to be looking at points, individual points for the x and y. Now, because number 10 is an actual line, we're going to have inequalities. So looking at number 9, the domain. So what are our x values for this here? It looks like our first one might be, what? -6. What's another one? -6. The x value for this one is -5. The next one is at what? -3. And then we have one at 1. The x value for this one is at 2. And our last one is at so we're really looking at just the x values of these points for the domain, because the domain is going to be the x values of each individual point. So we're looking at them and listing them out. So -6, -5, -3, 1, 2, 4 would be the domain. Any questions on this here so far? We go with domain. Now the other part we want to find is the range, the y values of each of these points. Well, the lowest one we have is at what? It'd be 1, wouldn't it? Well, this next point here going up is at what? 1, 2, 3. But I actually have 2 values where y is 3, don't I? I have 2 points that have a y value of 3 going across. So how many do I have to list them? How many times do I have to list it? ones, because we're saying we have a y value of 3, yes? Is that number listed in the range now? Yeah, we don't have to repeat it. It just needs to be listed at least once. We have to list it once. Going up, the next value is at 6. And even though it's shown twice, we only need to list it once. And the last one is at 8. 1, 3, 6, and 8. Any questions on number 9? We go to number 9? Yes. Okay. Let's look at number 10. Now, domain and range for a graph is going to be our inequalities. And when we have this here, we're going to have x less than or equal to and greater than or equal to on either side. And the same thing for y, because we're talking about all the values between these points. So the domain, we're wanting to talk about the x-axis. So if we're looking at just the x-axis, we're trying to see what does it cover? What values does this function cover on the x-axis? So when I look at the left side, because there is a point there, yes? So I kind of drew a dotted line down because this is the smallest value of x, which is what? -6. So -6 is less than or equal to x. We're saying this is the smallest value and it's going to be greater than it. Now we go to the other side to where it is the biggest value, which is this dot over here, which is at 5. So we're really taking the x values on the two endpoints, and those are our endpoints. Questions on this here? Okay, now we're going to do pretty much the same thing, except instead of looking at x, we're going to look at the y values. So looking at the y values, what is the smallest y value that this graph has? It would be that point there, wouldn't it? That point is the lowest spot on the graph. Is there any point lower than that one, where that v is? That's the y value. It would be -3, because that is the smallest y value. That's the smallest value in the range. Now we would go up to see what is the biggest one. If we went up to this direction, where would we stop? 8, because that is the biggest y value, yes? So the range for this here would be -3 is less than or equal to y is less than or equal to 8. Now it's fine that some of the values repeat themselves, like any of the values right here for y. That's fine, because we're just talking about what are the y values. The range for this here would be -3 is less than or equal to y is less than or equal to 8. That's it. Questions on this here? Now on 11 and 12, 11, again, we have points, yes? So that means our domain and range are just going to be numbers. We're not going to have inequalities. So looking at this here, so I'm going to just look at these points coming straight down. So what are our x values? Well, the smallest one would be at this point here, which is at -2, yes? And then the next one would be at Yeah, I'm just going to go left to right. Because 4 is 1, yes. We can list it. What's another one? Because we still have these two left. And 1, because we got 1, 2, and 1, 2, 3, and 4. So the order really doesn't matter. According to number theory, they would really want it ordered from smallest to biggest, -2, -1, 1, 2, 3, 4. But this is fine. It's fine. It doesn't matter. Okay, so that's the range, or domain. Now the range is going to be the y values. So it's going to be going up and down. So our smallest one is right here. So what's the y value of that lowest point? What's the y value of this point right here? Well, the x value is 4. 0. Because the value of y along that x-axis is 0. It's always going to be 0. So let's look at the next point. What is its y value? And then? And that's the range for these here. So we're looking at the x values and the y values. So I'm going to make sure to take good notes because there is not an answer key on this thing. We're making an answer key here. Any questions on this here? All right, let's look at the next one. Domain and range. So we know we're going to have to use inequality signs because we don't have points. We have a line, yes? It's actually a curve, but we don't have individual points. So when we look at the domain, we're looking at really the x values of the endpoints, yes? So what can we say about the domain for this here? What numbers would we put into this inequality? The smallest would be? Let's say -6, because that's the smallest x value, and it goes over to the biggest one, which is? So the domain for this here would be -6 is less than or equal to x is less than or equal to 6, because those are the x values that this function covers. Yes? Now, how about the range? What is the smallest y value? -4, because those are actually at the same point, aren't they? So -4 is the lowest it goes on the graph. What's the highest point it goes to? Huh? As it's coming up this direction, and then... So -4 is less than or equal to y is less than or equal to 3. Because the highest value, the biggest y that we have is 3. And that's it. Questions on this here? And I think this here is what y'all like the best, right next to some of the ones we've done before. Determine whether the graph is linear or nonlinear. So if it's linear, it makes a what? Straight line. So is 13 linear? So this 13 is linear. How about 14? This is non-linear because it is not a straight line, because if it is a straight line, it is linear. Kind of tells you. Linear. Four letters of linear is L-I-N-E, line. It's a line. It's linear. How about 15? 15 is? It's almost, but if it didn't make a turn right there at 0, 0, or it went from going down to going up, it would be. But this here is not linear because it is not a straight line. How about 16? Linear, because it is a straight line. It is a straight line. That's it. Any questions on these here? We good with these here? Determine whether the table represents a linear or nonlinear function. So it's considered linear if the change in x is the same, not the same as change in y, but it's constant. We have a constant change in x and a constant change in y. So from here to here, we do what? We added 2. From here to here, we added 2. From here to here, we added. There's a constant change from 3 to 5 to 7 to 9 to 11. We're going up by 2 for x, yes? How about from here to here? That is 16. What's 49 minus 25? Because I could subtract it, go 25 minus 9, and find the difference of 16. We could do 49 minus 25, which I believe is 24. $24. $32. So is there a constant change? There's a constant change in the x. Is there a constant change in the y? No. So is this linear? No, this is non-linear because the change in x and the change in y is not constant. Because every time we moved up 2 on the x, it was not moving up the same value on the y. Does that make sense? Yes? Let's look at the next one here. From 2 to 4, we did what? We added 2. From 4 to 6, we added 2. From 6 to 8, we added. And from 8 to 10, we added. It's 24 plus 8 is 32. What about from 32 to 40? What about 40 to 48? So is this linear? It is linear. Because we have a constant change in x and y. Let's say I added 14 and these two here. So this here would be plus 4, yes? What would this be here? Would be 20. What's 72 minus 56? See what the difference is. 8. 16. Would this still be linear? Yes. because what are we doing? Every time I go up 2, we're going up how far? 8, yes? Did I increase by 2 here? No, I increased by 4. So each time I increase by 2, the y value is increased by how much? 8, yes? So if I increase this by 4, I doubled the amount, yes? So this amount should be doubled as well. So it's not 8, it would be 16. So it's still linear. It's just we had a jump. We had a bigger jump there. Does that make sense? So it doesn't have to go this way, but it could, but they could jump. Okay, let's look at this next one here. Well, they put the y values on top. That's fine. So the change in y from 15 to 20 is plus 5. 20 to 25 would be 25 to 30. Well, here they're just adding. So is this linear? This would be linear. Any questions on this here? We feel pretty good with this here? Yes? So let's look at the next one. Okay, so they flipped x and y back around. So 21 to 22 would be plus 1. Plus 1, plus 1. What did they do to get from 50 to 54? Plus 4. 54 to 58. Okay, so it's constant. We can call this linear, yes? No. Let's keep going. Let's see what happens. What's 58 to 60? And 60 to 64 is plus. So is it a constant rate? Is it a constant change? No. This here would be nonlinear. Not really sure what it would be, because it's hard to have a function that would have that kind of change where it'd be constant except for that one point. That's it. Questions on these here? Okay. Evaluate each function when x is equal to 4, 0, and negative 3.1. What are we doing for these here? Yes, sir. Yes. We're plugging these values in for x. So when x is 4, we'd have 18 plus 0.2 times 4 squared. We're plugging these values in for x. At this point here, we can type it straight into the calculator. So in the calculator, you can type in 18 plus 0.2 parentheses 4 close parentheses squared. And if we type this in, and we could say really this is f of 4, we're just plugging 4 in for x. What do we get? What do we get when we plugged in 4? Did y'all get this answer here? I'm thinking 21.2. Is that what y'all got? Plugged it in? No. Yeah. 21.2. We just plugged 4 in for x. We can do it for f of 0. So we do 18 plus 0.2 times 0 squared. So what would happen if we plug this in? What would we get? Go on, try plugging it into the calculator. See what you get. It's 18. because 0 squared is still going to be 0. 0 times 0.2 is still 0. The only thing we have left is 18. Now the last one for this here. 18 plus 0.2 times negative 3.1 squared. Now I'm going to need y'all to do this one here because doing 3.1 or negative 3.1 squared in my head is a little hard. I don't have that memorized. Now make sure to put parentheses around it, because if you don't include the parentheses around that, it will not, it'll affect it. It'll affect the overall value. 19.92. Okay, 19.22. Is that what y'all got? 922. Thank you. 0.922. Any questions on this here? We good with this here? Okay. Now we would do the exact same thing for 22. So we'd plug in 4 for x. We'd have negative 1 minus 4 cubed plus 4. And we can type that into the calculator, and it'll tell us exactly what the answer is. And I believe it should be negative 61.
Wait, no, wait, I did that wrong.
So hit enter. Yeah, so enter. And you can say delete, delete, press 4. So negative 61. And again, we can just type this into the calculator and it'll give us the answer, yes? We can do the same thing with 0 and go negative 1 minus 0 cubed plus 4. And I think for those of you who did 0, I would double check and make sure that's the answer you got. And then we can go on and do the last one here, negative 3.1. And that's it. That's all we have to do for these here. Questions on any of this here so far? All right. Let's do these two here. And this will probably be the last two that we do today because the bell's about to ring in about 7 minutes, 10 minutes. Now these two here, find the value of x so that the function has the given value, so that the function equals this number. So for 23, we're trying to find out what value of x will make 7x equal negative 7x equal negative 28. We're trying to find out what value of x will make this happen, will make this work. So really what we're saying is solving this equation for the value of x. So what would we need to do first? Because negative 7 and negative 7 will simplify to just x. Negative and negative would make a, so 28 divided by 7 and And that's it. That's all it's asking for. It's really asking us just to solve these equations for the value of x. Any questions on this here? All right. So if we're good with 23, let's look at 24. So here we're saying negative 4 is equal to 1 half x minus 3. 1 half x minus 3. And again, because we're wanting to find out what value of x is going to make this function equal negative 4. Now looking at this here, again, we're trying to find the value of x. We're trying to get x by itself. So what would I do first to get x by itself? Add 3 to both sides. Because negative 3 plus 3 will, leaving us with 1 half x. Negative 4 plus 3.
Amy Cantaloupe, please come to the office. Amy Cantaloupe, come to the office.
What can we do next? We can divide both sides by 1 half. Because 1 half divided by 1 half will simplify to 1, leaving us with just x. Now, negative 1 divided by 1 half, you can type that into the calculator. There's nothing wrong with that. Negative 2. Now, with fractions, it works out. What we could have done also is multiplied both sides by 2. Because 1 half times 2 would give me 2 over 2x, yes? Well, 2 times negative 1 would be negative 2. Anything divided by itself is 1. 2 divided by 2 would give us 1, so we'd have 1x or just x. So with fractions, what you can do is multiply by its reciprocal or the flip. If we flip the fraction over, we can multiply by it and it will simplify. Dividing by also works. Either way works. Questions on this here? I feel like there's one more of these. Let's do this last one here, and this will be it for today. We'll finish up this review sheet tomorrow. So what we're saying for this one here is that negative 5 So let's finish this one here, and then we'll be done. So negative 5 equals negative 4/5 x plus 7. So we still need to get the value of x by itself. So the first thing I would do would be to subtract 7 from both sides, because 7 minus 7 is 0. 4/5 x is going to equal negative 5 minus 7, negative 12. What can we do next? We can. Well, we can divide or times. So I'm going to show division here. So I can divide both sides by negative 4/5, which would get x by itself. And you can type that into a calculator. And if we did that, we would get x is equal to 15. Now, if you want to do the multiplication, you flip it, you keep the same sign. So since it's negative, I'm going to multiply it by negative 5/4, because these will cancel. And if you plug this in, you would also get 15. If the division method makes more sense, do it that way. If the flip, the reciprocal, multiplying by reciprocal to reduce fraction makes more sense, do it that way. But pick the way that makes more sense to you.